In the constellation of Orion, a celestial giant flickers. This constellation, easily recognizable by its distinctive belt of 3 stars, has been a subject of fascination for stargazers for centuries. This is Betelgeuse, a red supergiant star nearing the end of its life. Betelgeuse is one of the largest and most luminous stars visible to the naked eye, and its reddish hue makes it stand out in the night sky. Betelgeuse is much larger than our Sun. In fact, it is about 700 times the Sun's diameter and shines with a brightness that is roughly 100,000 times greater. If it were in our solar system, it would engulf the inner planets. Mercury, Venus, Earth, and even Mars would be swallowed by this colossal star. It is nearing its end. As Betelgeuse exhausts its nuclear fuel, it undergoes dramatic changes, shedding its outer layers and becoming increasingly unstable. Astronomers have observed Betelgeuse dimming and brightening. This variability in brightness is a sign of the star's turbulent inner workings. This behavior suggests it is unstable. The fluctuations are caused by complex processes within the star, including pulsations and convective currents. Betelgeuse is a ticking time bomb. Its instability indicates that it is in the final stages of its life cycle. It will eventually explode as a supernova. This cataclysmic event will release an enormous amount of energy, outshining entire galaxies for a brief period. This will be a spectacular event, visible from Earth. The explosion will be so bright that it could even be seen during the daytime. The timing of this event, however, remains a mystery. Despite extensive observations, predicting the exact moment of Betelgeuse's explosion is beyond our current capabilities. It could happen tomorrow or thousands of years from now. The universe operates on timescales that are difficult for us to comprehend. When it does, it will be a sight to behold. The supernova will leave behind a nebula, a beautiful remnant that will continue to intrigue astronomers and inspire wonder for generations to come. Betelgeuse's path to supernova is a story of mass loss and nuclear fusion. This massive star, located in the constellation Orion, has fascinated astronomers for centuries. Its journey is a testament to the life cycle of stars and the cosmic forces at play. As a red supergiant, Betelgeuse is constantly shedding its outer layers into space. This shedding is a dramatic process where the star loses a significant portion of its mass over time, creating a beautiful yet chaotic scene in the cosmos. This process creates a stellar wind that carries away the star's mass. These stellar winds are powerful and can extend far into space, influencing the surrounding interstellar medium and contributing to the formation of new stars and planets. Inside Betelgeuse, a different kind of process is taking place: nuclear fusion. This fusion process is the engine that powers the star, converting hydrogen into helium and releasing immense amounts of energy. Betelgeuse's core is a furnace, fusing lighter elements into heavier ones. As the star ages, it begins to fuse heavier elements like carbon and oxygen, creating a layered structure within its core. This process releases the energy that makes the star shine. The light and heat emitted by Betelgeuse are a direct result of these nuclear reactions, making it one of the brightest stars in our night sky. However, fusion cannot continue forever. As Betelgeuse exhausts its nuclear fuel, the balance between pressure and gravity begins to shift. Eventually, Betelgeuse will run out of fuel. When the core can no longer sustain fusion, the star will face its inevitable fate. When this happens, gravity will take over. The core will collapse under its own weight, leading to a spectacular supernova explosion, a cosmic event that will outshine entire galaxies for a brief moment. The core of Betelgeuse is approaching a critical point. As the star runs out of fuel, the outward pressure from nuclear fusion weakens. Gravity, always present, begins to compress the core. This compression causes the core to heat up to incredible temperatures. Eventually, the core can no longer withstand the immense pressure. It collapses in on itself in a fraction of a second. This collapse is the trigger for the supernova explosion. The collapsing core releases a shockwave that rips through the star. Section 4. Neutrinos, the first messengers. In the vast expanse of the cosmos, there are signals that travel faster than the speed of light. These signals are not what you might expect. The first signal of Betelgeuse's supernova will not be light, but something far more elusive: neutrinos. These tiny, almost massless particles are the universe's first messengers, heralding the cataclysmic events in the stars. Neutrinos are subatomic particles that interact very weakly with matter. This means they can pass through entire planets, stars, and even you, without leaving a trace. They are produced in vast numbers during a supernova explosion. When a star like Betelgeuse reaches the end of its life, it collapses and explodes, releasing an immense amount of energy and particles. These ghostly particles will race ahead of the light from the explosion, traveling at nearly the speed of light. Unlike light, which can be blocked or scattered, neutrinos pass through almost everything in their path. They will arrive at Earth hours before the first light from the supernova. This early arrival gives scientists a precious head start in observing and studying the supernova event. Neutrino detectors around the world will record a sudden burst of these particles, signaling that Betelgeuse has exploded. These detectors, buried deep underground or in vast water tanks, are designed to catch these fleeting messengers from the stars. Section 5. A celestial spectacle for the ages. When the light from Betelgeuse's supernova finally reaches Earth, it will be a sight to behold. The star will brighten dramatically, becoming visible even during the day. For weeks, it will outshine all other stars in the night sky. Betelgeuse's supernova will be a once-in-a-lifetime event. It will provide astronomers with a wealth of data about the life and death of stars. It will also be a reminder of the vastness and wonder of the universe we live in.